everybody, welcome back to Algebra. Today we're going to be talking about 12-3 permutations and combinations. So what we'll be doing today is we will be calculating the number of ways there are to do something. So how many ways can I do this? How many ways is it possible? How many different selections can I make? And there'll be different criteria for each one. Then after we figure out the number of ways there is to do something, then we'll look at the probability of an event to happen. So we have things called permutations, combinations, but first let's just look at finding just a number of ways that things are possible. So here on example 1, we have the car that Miss Garcia is buying comes with a choice of 3 trim lines: standard, sport, or luxury. 2 types of transmission, automatic or manual, and 8 colors. How many different option packages does Miss Garcia have to choose from? And explain. Now, there are several different ways you could choose to solve this. But I'm going to boil them all down to 2 different types of methods. So method number 1 is our list or diagram method. So let's call method 1 the list method. List method would be where you try to list out all the possible ways. So let's say she's got 3 trim lines. So standard, sport, luxury. So we'll do ST for standard, SP for sport, L for luxury. Automatic or manual, and then 8 colors. So we could make a list. So I could say, okay, well, she could have standard with an automatic in color 1. Or she could have standard, automatic in color 2. Or standard, automatic in color 3. Standard, automatic, color 4. Anybody getting bored with this yet? Oh, this is taking forever. Who wants to do this? Not me. So the problem with method 1, making a list, it works. It's just going to take too long. This is going to take forever. Unless these numbers aren't very big, you don't have a lot to choose from. Okay. Method number 2, something called the fundamental counting principle. Fundamental counting principle. That's where you just take the number of ways that there are, number of things. There's 3 trim lines times 2 types of transmission and 8 different colors. And you just multiply them together. 3 times 2 times 8. There are 48 different options. So if I had continued my list for method 1, I would have 48 different things listed. And the danger with method 1, where you have to make a list, sometimes if your list is really long, you might repeat or omit things on accident. But the fundamental counting principle will work, and I will show you exactly what it is in just a second. So let me pull that up. So the fundamental counting principle states that if there are P ways of doing one thing and Q ways of doing another thing, then there are P times Q ways of doing both things. So in other words, as long as you know how many ways there are of doing each thing, and you pick one from each, then you can just multiply all those together. So that's pretty nice, fundamental counting principle. Now let's look at a related idea. So example 2 is to find the number of permutations. Now you don't have this first one written down in your workbook, but I feel like it's just helpful for having some background information. So our scenario, we've got this girl named Gabriella. She's going to make a playlist with 3 of her favorite songs. How many possible orders are there for the songs? Actually, with not 3 of her favorite songs, it's her 3 favorite songs. So that she's got 3 songs all together. She's going to make a list. Well, that's not what you have in your workbook. You have this question. It's really similar, just there wasn't as much written down. Okay, so how many possible playlists are there for each situation? This time, for Gabriella's 4 favorite songs. So this is not 4 of Gabriella's favorite songs. She's making a playlist and only her favorite songs are on there, because why would you want a playlist that didn't have your favorite songs? Okay, so let's try this. There's a couple different ways we can do this. First one, method 1. We can make a list. So let's say she's got a favorite song. We're going to call it favorite song number 1, favorite song number 2, favorite song number 3, favorite song number 4. All right, so one order of the list could be the first song, the second song, the third, and then the fourth. Or maybe song 1 is really upbeat, but then Gabriella's like, hey, let's play a little song 4 first, and then 3, and then a 2. Or maybe she wants to do the first song and then the third song and then the second one and then the fourth one. Or maybe she wants to do 1, 2, 4, 3. See what I'm saying? Like maybe Gabriella just wants to change it up as she's going. Now, once again, this method is taking a little bit too long because we've only made a set of 4 possible playlists, and every single one of them has her number 1 song as the favorite song, because she could also have number 4 song come first, and then 3, then 2, and then 1. Maybe she wanted the 4th song first, and then the second favorite one, then the first favorite, and then the third. This is taking forever. So here's our second option, method number 2. Okay, method number 2 works like this. There are 4 songs that are going to be on the playlist, right? So I'm drawing 4 blanks. Okay. How many songs can she choose from for the first one? Well, she hasn't put any songs on her list yet, and there are 4 favorite songs. So right away she has 4 songs first. Then, if for the second song in the list, how many choices does she have left? Remember, she's only got 4 songs here. She's used one of them. Well, this is getting confusing. So then there were 3 songs left. And then 2 songs would be left for the second one, and then 1 song left. So 4 times 3 times 2 times 1 would be 24. So there are 24 possible different playlists that Gabriella can make. Just by changing the order of her 4 favorite songs. Here's a related question. Now Gabby's going to pick 5 of the 10 most popular songs. So let me Google the 10 most popular songs so we have some titles to look with. Let's make this a little more fun. So just in a Google search, These are the 10 most popular songs as of 10:47 p.m. on February 21st, according to Billboard. Let me show the whole thing. All right, so let's say that this time Gabriella wants to make a playlist of 5 of the 10 most popular songs. Now, let's say Gabriella picks maybe these 5, the first 5 in the playlist, but you would still have a different playlist if they're in different orders, because maybe sometimes you might want to do Blinding Lights first and then Save Your Tears and then Mood and then Driver's License, or it would be a totally different playlist if Driver's License were first and then Up, then maybe Save Your Tears and Blinding Lights. So the order, whoa. So the order of let's just go ahead and say it. It's going to matter. The order of the playlist matters. Definitely matters. Okay, so then we're going to make a playlist of the 10 most popular songs, or 5 of the 10 most popular songs. So that means my playlist has room for 5 songs. 3, 4, 5. So I'm going to multiply things. So I'm still applying that fundamental counting principle here, ish, like kind of doing it. Okay, so 5 of the 10 most popular songs. So for my first song in that playlist, I have 10 songs possible. So I've got 10 there. So let's say I just so happen to pick Mood. Okay, so now I've got 9 left for the second. So let's say my second one just happened to be Blinding Lights. Okay, so that leaves how many left? 8. So then let's say that third song was Go Crazy. That leaves 7 left for my 4th song. So let's say it was Up. And then my last song, that means I have 6 options left. So 10 times 9 times 8 times 7 times 6 equals, holy cow, 30,240 different playlists. Pretty cool, huh? Now, let's talk about what else we can do with this. Okay, so what we just did is something called a permutation. A permutation is an arrangement of objects in a specific order. So in other words, order matters. The number of permutations of R objects taken from a set of N objects is following this formula. So this is NPR. The P stands for permutations. N is the number of objects. R is the number you choose. And then this is the formula. This exclamation point is a factorial symbol. So the factorial symbol, like 3 factorial, means 3 times 2 times 1. So I'd multiply everything, every integer until I got to the number 1 below it, over n minus r times 1. So we'll do this with the formula, and then I'll also show you how to do it with a calculator. I'm going to show you how it works with the formula, but then know that you will most of the time be able to use a calculator as well. So here's my formula. Yeah. And I'll go back and work this out with a formula as well. Now, because we established that order matters, then I can say that this is going to be definitely a permutation. Remember, it's NPR. So my N, the number of objects available, there's 10 songs. I'm going to make a permutation of 5 of them. So that formula is N factorial over N minus R factorial. So the N would be 10 over 10 minus 5, and each of these is factorial. Now I'm going to show you how this works out the long way. 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 10 minus 5 factorial, let me just carry everything over. 10 minus 5 is 5, so 5 factorial. So on the bottom I would have 5 times 3 times 2. Oh, I forgot 4. How did I forget 4? 5 times 4 times 3 times 2 times 1. Okay, so because I am dividing and there's only multiplication happening, I can divide out a number by itself. So like 5 divided by 5 is 1. 4 divided by 4 is 1. So I'm kind of canceling out these. 3 over 3 is 1. 2 divided by 2 is 1. 1 divided by 1 is 1. So I'm left with 10 times 9 times 8 times 7 times 6, which is 30,240. Or I can pull up a calculator and use the permutation feature there. So on Desmos, I'll show you where that is. You'll go, it's in your functions part under the stats, choose NPR, and that N is going to be the first number and the R is the second number. So we're going to do 10, and then you do have to type a comma, 5. And look, 30,240. Now, I will say it is nice that you are familiar with it. Let's see, go back to this whole thing. It's nice that you're familiar with the factorial notation and that you recognize it. Sometimes you might have a multiple choice question come up where you just have to recognize the formula, but the majority of the time you'll be able to use your calculator. So let's keep going. Permutations. The other thing you need to know about is something called a combination. Now for combinations, the order does not matter. So for this one, how many ways can a camper choose 5 activities from the 10 available? So this picture is not in your workbook, so you might want to make a list. But it says choose 3, but it should say choose 5. But it's vital information for this. So here, these are summer camp activities. It says we're going to choose 5 from the 10 available. I'm just going to make sure that there are 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 5 from the 10 available. And order doesn't matter because no matter what, if you choose climbing, cooking, fishing, you'll still be participating in those activities. And we're not really concerned about the order that they happen. We're just concerned about the fact that you participated in them. So there is a formula for combinations. Here it is. N factorial over R factorial times N minus R factorial. The N is still the number of objects. The R is the number that you're choosing. And then NCR. So since I said we're going to use our calculator most of the time, we'll just go ahead and do our calculator here. So you have 10 activities. I'm going to choose 5 of them. So I'm going to calculate 10 combination of 5. So then let's look at Desmos. That's NPR. Let's find NCR. Functions, stats, NCR, 10, comma 5, 252. See, when the order doesn't matter, there's a lot fewer possibilities. So 252. Now, if you really do want to set up the formula, it would look like this: 10 factorial over 10 minus 5 factorial times 5 factorial. But it does come out to be 252. Now, the biggest issue you'll have is you'll have trouble deciding. Well, you won't have trouble, but you'll just have to focus on deciding, does the order matter or does it not? If it does not matter, choose combinations. If it does matter, choose permutations. All right, so now let's see how this is involved with probability. So you do not have this one in your workbook, but you do have this. This is what you have, but you need this picture. So we're going to use you just need the picture. You don't need this. There you go. Well, kind of. You need this scenario here. Okay, so example 4, teacher chooses 5 students at random from the names shown to work together on a group project. So here's the names. What's the probability that the 5 students' named chosen begin with a consonant? Now, we're not going to answer that because we're going to do the one that's in your workbook. The 5 names end with a vowel. And we're asking probability. So how many students are there total? Let's gather some information first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so there are 18 total students. Okay. The other thing we know is we know that the teacher will choose 5. Because sometimes if you don't know what to do, maybe just stepping back, reading and writing down all the information kind of helps your thoughts. So the teacher chooses 5. We're trying to calculate the probability that the 5 she chose end with a vowel. So how many end with a vowel? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did I leave anybody out? On my paper I have 13 written down, so I'm just double checking myself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we're going to say 12 of them end in a vowel. Okay, so we're calculating probability. So remember, probability in general is the number of favorable outcomes divided by the total number. Well, here we're dealing with how many ways could that happen. So, and we're going to be looking at the number of favorable ways that could happen. So the total number of ways it could happen divided by the total of number of ways in general. Okay, so first of all, we're trying to calculate the probability that 5 students named end with a vowel. So let's talk about the total number of ways. To draw 5 students. Out of 18. Well, does the order matter? Nope, we are not assigning roles, so the order does not matter. So that would be a combination of 18 students choosing 5. Okay? Now the number of favorable ways. So the number of ways I can choose 5 students ending in a vowel. Well, there are 12 students whose name ended in a vowel, and I want to choose 5 of them. So for the probability, the total number of ways is going to be the 18 choose 5, 18 combination of 5. The number of favorable ways would be that there's 12 students that end in a vowel, and I'm going to choose 5. How I could choose 5 from the 12, and then I'll do that division. So 12 choose 5. Let's see, combination, 12, 5, 792. Divided by 18, choose 5. 18. 8568. And then I'll just divide that. So 792 divided by 8568. About 0.9. Approximately 0.9. So there's about a 9% chance that all 5 students picked and did a vowel. 0.09. Just double checking. So I'll circle this. That's my answer. I believe that's all for today. Yes, it is.